Hello class, today we are going to talk about the triangle midsegment theorem. As it says right there on the front. Triangle midsegment theorem. So no more centers and stuff. Makes it a little bit better. Now, before we can talk about the triangle midsegment theorem, what we have to talk about is what is a midsegment. Right? Well, a midsegment, very simply, is a segment that connects the midpoints of two sides of a triangle. So it's the midsegment because it connects midpoints. Very simple. So point M is a midpoint of side AB. And we know that because we see that AM is marked congruent to MB. So M is the midpoint. Point P is the midpoint of side BC because we see PB and PC are congruent. So M and P are midpoints, so therefore segment MP is the midsegment because it connects the two midpoints. N is also a midpoint, so we have more midsegments there. NP is a midsegment, MN is a midsegment. These are all midsegments. And we notice that these three midsegments, they make a triangle that looks very similar to the other triangle. This triangle that is made up of midsegments is called the midsegment triangle. Okay, so we have triangle ABC and midsegment triangle MNP. Okay, so that's great. That's lovely. What can we do with it? So this gets us to the midsegment theorem. Now that we know what a midsegment is, there is a theorem for this. What does this theorem say? So, the triangle midsegment theorem. What this says is that the segment connecting the midpoints of two sides of a triangle is parallel to the third side and is half as long as that side. Okay? So, in other words, the midsegment is going to be parallel to the side that it is not touching, and it's going to be half as long as that side. So, DE is our midsegment because it's between two midpoints. DE is parallel to AC, and DE is going to be half the length of AC. Okay. So that's cool. That's interesting. That's pretty easy stuff. Parallel, half the size. So not a whole lot here. And that's the midpoint, so these two are congruent. Those two are congruent. So this is actually a pretty good, easy lesson. Not a whole lot to it. So 1 through 3 tells us that segment DE is a midsegment of triangle ABC. We need to find the value of x. All right. So on this first one, DE is the midsegment, gives us BC. BC is this third side. It's the side that the midsegment is not touching. So what that means is that BC is twice the length of DE, or DE is half the length of BC in this case. So DE equals 1/2 of BC. So that is 1/2 of 28, and DE equals 14. All right, so that is x equals x. All right, because it does ask for x, not DE. Same thing in this case, but that's okay. All right, number 2. Just as easy. In fact, I would like you to pause the video and see if you can do 2 and 3 on your own, and then come back and check the work. All right, let's see how you did. DE on number 2, that's our midpoint, because it tells us midsegment. So DE is our midsegment, our midpoint, midsegment. It is not touching BC, so that means DE is half the length of BC. So 15 equals 1/2 of x. So we just solve for x, multiply both sides by 2 times 2 times 2, and 30 equals x. Just like that. Not too bad. Okay, number 3, DE is the midsegment. We're looking for x. X isn't a midsegment, it's not this other side, it's not any of that. What do we do with that? Well, if this is the midsegment, that means E is the midpoint, right? Just like this. That means these two segments are congruent. because it's a midpoint, so it bisects that segment. So very simply, x equals 9. That was easy, right? All right, so that's not bad. Let's open this up. Let's get to some things that are a little bit more complicated. Okay, so let's adjust my camera. Here we go. Tells us the vertices of a triangle are A at -5, 6, B at 3, 8, and C at 1, -4. We need to find the vertices of the midsegment triangle. And remember that midsegment triangle, that is the triangle that is formed by all 3 midsegments. Okay, so first things first, I need my straight edge. What did I do with it? It is right there. All right. Straight edge. Okay. So first we need to draw the triangle. Let's see, what can we do with our axis since it didn't give us one. See, x's are going from -5 to 1, so that'll fit going up by 1s. Y, 6, 8 down to -4, and I've only got 10. That's a spread of 12. So this is not going to fit with a scale of 1. We're going to have a scale of 2, which is annoying, but that's okay. So we can stick this in the middle here. And if I got a scale of 2, I can put my center in the middle, which is all right. Okay, so there's my axis. It's a little that's better. And we're going up by 2, so I need to note that, otherwise I will forget. So this is 2, 4, 6, and we're going up by 2, 4, 6. Okay. So A is at -5, 6. So -2, 4, 5, and up 6. Okay. There's point A. B is at 3, 8. Way up here. B. C is at 1, -4. 1, -4. Right there. C. All right. Let's connect the dots, make a triangle. Always use a straight edge for this. Don't freehand it, otherwise things get all wumper-jarred and it doesn't look good. I know I say this a lot in just about every video, but that's because it's important. That's why I say it all the time. Okay. So there it is. There's our triangle. We need the midsegment triangle. So where do we put that? Well, if we'll remember, a midsegment connects the 2 midpoints. Right? So we just need to find our midpoints. That's not too bad. We remember the midpoint formula, right? Midpoint formula, you take your 2 x's, add them up, divide by 2. Then you do the same thing with y's. Y1 plus y2, divide by 2. So first, let's find, we'll call it point D. Why not? And so D is going to be the midpoint of AB. So A, we have x1 plus x2, coming from point B, divide by 2. And then we do the y. So 6 plus 8. 6 plus 8, divide by 2. All right, so -5 plus 3 is -2, divide by 2, and so this is going to be -1. And then 6 plus 8 is 14, divide by 2 is 7. So that's my first midpoint, is at -1, 7, right there, and we'll call that point D. Now let's find our next one. We'll do BC. We'll call this point E. So BC, we need the midpoint there. So x1 is 3 plus x2, which is 1, divided by 2. And then y1, which is 8, plus y2, which is -4, divided by 2. Okay, so 3 plus 1 is 4. 4 divided by 2 is 2. 8 plus -4, so 8 minus 4 is 4, divided by 2 is also 2. All right, so our next point is at 2, 2, right here, and that is point E. And now let's find point, we'll call it F. because it doesn't say what to call it. And this would be midpoint of AC. So x1 from A is 5 plus x2 from C, which is -4, so that's really going to be -4, divided by 2. And then our y's. Oh, wait. C, no, I messed up there. X is 1, so this is going to be plus 1. There we go. Positive 1. And now the y's. So y1 is 6 plus y2 is -4. Divided by 2. Okay, so -5 plus 1 would be -4 divided by 2 is -2. And then we have 6 plus -4, so 6 minus 4 is 2, divided by 2 is 1. So that means this is going to be at -2, 1. Right there, there's F. So those are the vertices, and we'll go ahead and draw it in, because we want to see the midpoint triangle, right? Or the mid-segment triangle. Don't want to just, get the coordinates. We want to draw it out so we can actually look at it. Like that. There it is. So there is our mid-segment triangle. The answers are just the vertices right here, the coordinates. That's our answer. All right. So again, not too bad. It's just the midpoint formula, and we've been doing that since the beginning of the year, right? So easy stuff. Just add them up, divide by 2. Okay, let's take a look at number 5. Number 5 wants to know what is the perimeter of triangle DEF. And if you'll notice, it doesn't give us any of the sides for triangle DEF. Not a single of those sides is given to us. So that makes it a little bit difficult to find the perimeter. So let's see, what else do we know? All right. Well, we know that these two are congruent, which means D is a midpoint. And those two are congruent. AE and EC are congruent, so E is a midpoint. And BF and CF are congruent, so F is a midpoint. Well, if these are all midpoints, that means this is the mid-segment triangle, because these are all mid-segments, because they connect the midpoints, right? Well, great. How does that help us? Well, if you remember, we said just a minute ago that the mid-segment is half the length of that side that it's not touching, right? So what that means is DE is half the length of BC. So let's go ahead and write this down. DE equals 1/2 of BC, and BC is 45. So 1/2 of 45. Okay, so 1/2 of 1/2 of 45, so that's 45 divided by 2. So 4 divided by 2 is 2, 5 divided by 2 is 2.5. There it is. So that means DE is 22.5. I'll go ahead and put it on the paper. 22.5 DE. So let's see, we need EF. Just go around the corner. EF is going to be 1/2 of AB. So 1/2 of 13. Well, half of 13, that would be 6.5. 6.5. And then we still need DF, FD, and that is going to be 1/2 of AC. So 1/2 of AC, which is 38. So half of 38 would be 19. 19. And now all we have to do is add up all the sides. So that would be 22.5 plus 6.5 plus 19. So 5, 0 carry to 1. That's 10 and 8. Renumber decimal. So 18 and 1 and 2 and 1 is 4. So my answer is 48.0, or just 48. Now, that being said, I want to take a look at this. There's some other stuff we can do here. This side is half of that side, right? This side is half of that side, this is half. So all of these sides are half the length of the original triangle, right? So watch this. Let's just take the original triangle and add those up. 13, 38, 45. All right, so 8 and 8 is 6, carry that, and that's 2, and 5, 9. The original triangle has a perimeter of 96. All of these segments are half the length of the sides of the original triangle. So all we really have to do is take that 96, divide by 2, and we get 48. So another way to do it, a lot of times it's going to be easier because we don't have to mess with all these decimals, right? We just add up the numbers it gives us, divide it by 2, equals 48. Because if you remember, when you reduce the size of a figure by a scale factor, and all of these are reducing by half, then it reduces the perimeter by that same scale factor. So if we're cutting all of the sides in half, it cuts the perimeter in half. All right. So a little shortcut, kind of nice. Always like shortcuts. Okay, so let's take a look at number 6 now. In number 6, it tells us that segment DE is a midsegment of triangle ABC. So triangle ABC, the big triangle right there. It tells us that segment FG is a midsegment of triangle ADE. So FG is the midsegment of this kind of smaller triangle. We want to find the length of FG. All right. Well, FG is the midpoint of this triangle, or the midsegment of this triangle, which means that FG is half the length of the side that it's not touching. So FG is half the length of DE, right? So this is one half of DE. Well, DE is the midsegment of the large triangle, so that means DE is 1/2 of the side it's not touching, so 1/2 of BC. So BC, I know, BC is 52. So 1/2 of 52 is 26. Now I'm going to take that and plug it in here. 1/2 of 26 is 13. And there's my answer. So okay, I'm just dividing by 2. All of this, I'm either dividing by 2 or multiplying by 2. It's really pretty easy stuff. So I like midsegments because they're easy. Okay. Let's take a look at number 7. Adjust the camera again. Here we are. Number 7. The area of triangle ABC is 48 centimeters squared. Segment DE is a midsegment of triangle ABC, so we want to find what is the area of triangle ADE. I say we draw a picture, because otherwise it doesn't make a whole lot of sense, right? Just going to sketch this out. Triangle ABC. Now, somewhere on here, I also need segment DE as a midsegment. And we know, does it go here? Does it go there? Does it go across? Where does it go? Well, let's see here. We need triangle ADE. So I need A and then DE. So I can have triangle ADE. So it's going to go here. DE. Okay. We need to find the area of the little triangle. I know the area of the big triangle. We need the area of the little triangle. Kind of weird, kind of hard to tell. Let's take a look at this. Look at this triangle that we had right here on number 5. All right. Notice the markings. We have triangle ADE and triangle DBF. All right. Notice these two sides are congruent. Well, DE is half the length of BC, which means it's congruent to BF, right? Because BF is half the length of BC because that's the midpoint. And that's what a midpoint does, is it divides it in half. So this is congruent to BF. And DF here is half the length of AC, which means it's the same length as AE. So these two are congruent. And if you'll notice, we now have side-side-side congruence. These two triangles are congruent to each other. All right? And what about FE, just to finish this off? FE is half the length of AB, which means it's congruent to BD. And once again, I have side-side-side congruence there, and I even have side-side-side congruence on this interior triangle. So all four of these triangles are congruent, aren't they? So how does that help us with this? Well, if the area for the entire thing is 48, and it's made up of these four congruent triangles, that means that each of these four triangles, since they're congruent, they have the same area. So I can just take this 48 centimeters squared that I have for the whole thing and divide it by 4. And so the area of triangle ADE is 12 centimeters squared. And so I don't need to know what the measurements are on any of these. All I need to know is, hey, this is a midsegment, so it cuts all of this in half, and so my area is going to be 1/4 because I have these four congruent triangles there. All right. All right. So that's nice and nifty. Let's take a look at number 8. Last one, a little bit longer. Well, not much. 2 steps. So this diagram shows a triangular woodshed. We want to install a shelf halfway up the 8-foot wall that will be built in between the 2 walls. All right? So we've got a woodshed, probably got a door here, and we just throw wood in here. I want to put a shelf, right? Question A, how long should this shelf be? Well, it's going to be from this side to that side. Well, we said we wanted to build it halfway up, right? Halfway up the 8-foot wall, we're going to build this shelf. So if it's halfway, that means that this is a midpoint, and we're going to go straight across there to the other midpoint, right? Because we want it to be parallel. And remember, midsegments are parallel to that third side. So we want this to be parallel to the ground, otherwise all of our stuff falls off the shelf. That's not good. So it's a midsegment, which means it just needs to be half of 15, which makes it half of 15 would be 7.5 feet. Okay, not bad. Now, question, we want this to be level, right? So we want it parallel to the ground. How many feet should we measure from the ground along the slanting wall to find where to attach the opposite end of the shelf so it's level? So what this is saying, important thing here, we want to measure along the slanting wall. So that means we want to measure from here along this wall right there. And we want to know how long is that. Well, remember, this is the midsegment, which means this is going to be the midpoint of the wall. So all we got to do is find how long is half the wall. Well, the whole thing is 17, and we want half of it, so we're going to divide it by 2, and 17 divided by 2 is 8.5 feet. And there it is. And that is midsegments. And we got a couple of word problems in there and stuff, application for life and how this stuff actually works. You can build shelves and things with it, make it look good. So, midsegments, just to recap, they connect the midpoints of 2 sides. If you have all 3 of your midsegments, you get another little bitty triangle there called the midsegment triangle, which we saw is 1/4 the size of the whole thing, and it divides it into 4 congruent triangles. Okay, triangle midsegment theorem says that the midsegment is going to be parallel to the third side, and it's going to be half the length of that third side. All right. So hopefully that helps. Hopefully you find that useful, and I will see you next time.